Hello, in this video we'll be going over SQL deployments on EFSeries using the Centricity System Manager. Reasons to use EFSeries are that it's fast, driving business value while reducing cost with performance-optimized IOPS and throughput. EFSeries is simple, with best-in-class solutions for integrated appliances, appliance plugins, APIs, and secure web-based management. EFSeries is also reliable, with 6.9 reliability and successful deployments in many of the world's most demanding environments. EFSeries offers benefits in the form of increased performance, disk management and monitoring through Centricity System Manager, and the lowest price point entry-level systems with the EF280 and E2800. In this brief demo, we'll go over volume creation using Centricity templates, volume initialization, database creation over multiple volumes, and more. From the Windows host that is connected to our EF storage, we'll first check Task Manager to quickly verify the number of cores that the machine we're working on has equipped, as it's important that if the server has more than 8 cores, we create 8 volumes. If it has less than 8, then we'd create the same number of cores and volumes. From the Centricity Storage Manager web portal, we can navigate to the storage, select pools and volume groups, and create the pool that will host our data. Once we've created the pool, we can begin creating volumes. Right off the bat, we can assign these to our host SQL Server prod. Our workload is specified next, and we'll opt to create a new workload from the Microsoft SQL Server template. For consistency, the name we'll provide for the workload will also be SQL Server prod, and the capacity we'll allocate for this workload will be 1000 gigs. System Manager then lets us pick and choose how we would like to divide the workload to however many volumes we specify for our database, temp, and log volumes. From this next page, we can edit the names to our liking, and we'll name each of the volumes according to the workload name, followed by the volume index number. After reviewing the volumes we're creating, we can select Finish and return to our Windows host. Opening Disk Management shows off all of our newly mapped and uninitialized disks. After initializing, we can fill the disk with a new simple volume and assign a mount path with the C MS-SQL directory. When formatting, we'll want to select a 64K allocation unit size as recommended by Microsoft. Now that the log disk is completed, we can repeat the process for the temp volume, also giving it a C MS-SQL mount point. Again, when formatting, we want to be sure to select an allocation unit size of 64K. Using the following PowerShell script, we can automate the process of initializing our remaining 8 data disks. The script stores all of our uninitialized disks in the disk array, which we then iterate through, creating each mount point directory while initializing disks and formatting each drive. In the C MS-SQL directory, we can see the results as the script runs in the background. From SQL Server Management Studio, we'll expand the Databases view to look into the properties of our tempdb database, which is currently mounted locally along with all of our other temp database files. The following Transact SQL script first modifies our database file names from the default to be more consistently numeric, and then moves them each to the newly mapped EF storage at the mount point specified earlier, with each file sitting at a size of 10 gigabytes. In order for the tempdb file changes to take effect, we'll restart our SQL Server, and once we do, we can see our 8 tempdb files and 1 log file with their new names applied. Our next script is going to initialize our new Feline Friends database files In each of our mounted EF volumes, we previously mapped using the PowerShell script. After executing this script, we see that each data volume now contains their corresponding database file. Refreshing the Databases view from SQL Server Management Studio reveals our new Feline Friends database. If we create a new customer table for the database, save that table, and look into the table's properties, we see that it has been assigned to the primary file group. Because the table belongs to the primary file group, we know that the data from the table is being spread across our 8 EF volumes to get the best performance out of this configuration. In summary, we've shown that the NetApp EFSeries is more than capable of high-performance workloads, such as this one for our SQL Server databases. Also that they are easily deployed for SQL Server workloads using the provided templates, and that it's easy to spread a workload over as many volumes as necessary. Thank you for watching. For more info, be sure to subscribe for more coming videos.